Hi, and welcome to another Hopper on 6502 video. This one's a follow-up to the previous one where I'm building this new hardware to make basically an easy way for other people to create these boards. This is my Hopper 6502 assembly toolchain, and this is the Hopper Minimal Runtime here. So you can see it does things like all these commands that we do in the Hopper Minimal Runtime, like loading up a new program, loading up a new program, and stepping through it, starting, debugging, single stepping, and all that. So let's build this. So if you see the bottom of the screen, pre-processing, assembling, optimizing, and then it should just generating the code. Okay, so we're building the minimal runtime using the Hopper toolchain, and we've succeeded. And now I'm going to use my see it on the screen. I'm now going to burn my ROM with it. So let's do that. Yeah, burn a ROM with it. So I've got a EEPROM programming here that you can't see on screen. Won't take long. Load it up, and we'll program it. And it's finished programming. You saw some flashy blue lights here, I hope. We'll take the ROM out of there and pop it back in the machine. Power up the machine. There we go. Okay, so we've got a machine powered up. Let me just make that a lot smaller. Like that. There we go. And now let's go and find ourselves a program, one that we're familiar with. So, well, firstly, we check that it's there. We run the Hopper monitor. Takes a little while. There we go. Let's look at the 0 page. Yep, it's there. And if I do that, do we get flashy lights while it happens? Yes, we saw a little bit of blue flashy light there. Look at 0 page variables. We've got a bit more flashy light going on. And so I know I've already built my Mandelbrot. So let me load that up. Mandelbrot. Loading the program. There we go. F5. And yeah, you can see there's activity on the serial port in that FTDI adapter there. The little blue light flashing. That's every time it's sending one of these characters back down the serial port to the console here. So there we have it. We've got a little 6502 computer in a bird's nest on a breadboard running the Hopper runtime. I'll do another little demonstration after this, and then wrap it up. So this is using the Hopper monitor, which is similar to Wasmon, but with a few more commands, sort of a console level. And in the Hopper monitor, you can do source level debugging of the Hopper runtime virtual machine instructions. So I use this to debug the runtime. A user wouldn't use it. A user would edit their program in the Hopper IDE like this. So this is Fibonacci sequence. So let's build that. I think this takes about 48 seconds or something to run, but let's do that. So if I F5 this now, I've built it. So I built actual Hopper code here now, not assembler. And if I F5, it will launch it into the debugger. It takes a little while. Successfully uploaded. At the bottom of the screen, it says it's successfully uploaded that. And now if I single step through it, so I'm F11, I step in, step in, step in. And let's move that video out the way. So move the video out a bit. As I step through here, you can see the variables in the watch window on the right, and I'm over here now where the gray line is. So if I step through there again, step another. So as you can see the recursion stepping, you can see the stack on the right here growing. So if I do Alt-Shift F5, it reloads. So it started at the beginning again. And then if I Control F5 to run without the debugger, without breakpoints, it'll take about 48 seconds to do the Fibonacci sequence to so it's Fibonacci 24 by default here, and the answer should be 46,368. Anyhow, so we're making progress. I've got a little breadboard 6502 here, ready to design the PCB for it so we can make machines that other people can build as well. And it's running the Hopper Minimal Runtime already, so it's got a firmware running on it. It's got I've written another video about all the features of this board. It has a 6850 serial chip. There you can see the Fibonacci has come back with the results, and 42 seconds to execute this benchmark. This is a benchmark I made to run on the RP2040 devices, so it takes a little long on the 8 megahertz 6502, but it's not so terrible. Anyway, summary of the device. It has a 6850 Motorola UART, which is a very reliable chip and very simple to program with its own CAN crystal. It's got a 1.8 megahertz crystal, so it's running by default at 28K. We could get it to easily run twice that speed at 56K. The CPU itself, 6502, it's a 65C02S, in other words, the Western Design Center version with more instructions, and it's got its own CAN crystal. It's running at 8 megahertz. We've got a reset chip in here to manage the power on reset properly. It's got a non-maskable interrupt break button. The address decoding is being done with a CPLD. I've got a whole Hackster article on how to program those. So all the glue logic's in a single chip. It's got a ROM chip, RAM chip, and then it's got the VIA over here, which is also from Western Design Center. I've got some LEDs on there. Those are like GPIO pins. So I guess I could do a simple blink program with it too, because the VIA has time in it. So I've got a millis API and I've got a seconds API, which I use here in benchmark to time how long it benchmark took. That's how it knew it took 48 seconds. So it looked at the seconds before, and then the elapsed time is seconds at the end minus start. So it's got a seconds API. The resolution of the timer is in milliseconds to the nearest millisecond, but I've got an API that divides that by 1,000 to give you seconds as well. So you can get either. You can ask for either. There's a delay API that uses the timer as well. Anyway, pretty cool little device, and it gets its power from the serial port. So it gets its power through that same wires as the FTDI, which means you don't need an extra power supply for it or anything either. It's going to be a really neat little board once it's on a PCB in terms of a way to run your code on an actual 6502. There's another link here to what I've done with the 6502 assembly tool chain. And then I've done one more video on this series on the hardware so far, and I'll do another one once I've got the PCB. Thanks for watching.